What's good, my statisticians? It's your girl, Professor Sampson from PS I Love Math, back with another statistical banger. You know, I'm hitting 1, 2, 3, 4 in a day. So this is the fourth and maybe last video on hypothesis testing with 2 samples. So before we get into that right quick, don't forget to subscribe to my channel and like and comment and all those things, and let me know how your statistics class is going. Is your professor putting out bangers or are they putting out duds? So just let me know in the comments below and I'll be happy to help you with anything. But anyway, that's enough. The intro is long enough. You want to get to the problem. So as usual, I'm going to share my screen and I got some information here so we can get started on this problem. So let's take a look at this problem here. I don't know why this is there, but we'll figure it out. So anyway, what we're doing today is we're covering proportions. The good thing about proportions is that we don't have to worry about mean, and we don't have to worry about sigma known, sigma unknown. It's just one, it's just Z, so we good. So to test the fairness of law enforcement in this area, a local citizens group wants to know whether women and men are unequally likely to get speeding tickets. 200 randomly selected adults were phoned and asked whether or not they had been cited for speeding in the last year. Using the results in the following table and a 0.05 sig level significance, test the claim of the citizens group. Okay, let's get started here. So as we want to start out, as usual, we want to do our null and our alternate, okay? So I'm going to put it over here out of our way. Right? Well, if I stop trying to write an eraser. So the null is obviously going to be what? Well, we have proportion 1. We have some proportion for the 1 and proportion for the 2. So we're going to go with proportion 1 is equal to proportion 2. That means there's no different. Everything's kosher. Don't worry about it. It's all good. Okay. So let's move to the second one. Now, now what is it here? Now I haven't done one like these, so hopefully you've been watching the channel, you watch this one, because I haven't done one like this. We don't want to know if it's greater than men or greater than women or women are less than men. We don't want to know either one. We just want to know if they're unequal, if they're just different. So that's going to be P1 is not equal to P2. So whether it's greater than or less than, we don't care. They're just trying to figure out whether it's different, whether there's something different. Okay. So again, the good thing about the Z-score is that the good thing about proportions is there's only one Z, and that's the Z-test statistic, all right, which I am going to pull up here in my list of formulas on my formula sheet. Okay, we got it right here for the difference between two proportions. So we have Z equal P hat 1, P hat 2, all over a whole bunch of crap. So we're going to write that out. And again, I don't know how your instructor is, but I am a combination of hands and calculator work. So you have to show me that you know what you're doing in order to get credit, okay? Not just popping stuff in the calculator and praying that it come out right, okay? So let's get back to our paper so we can write down our information here. So the formula is P hat 1 minus P hat 2 minus basically the regular proportion, but we don't have this. This is the population, but we won't have that in this problems. In most of your structures, you won't have it. And then it's going to be P hat 1 minus P hat times. Now, some books will have this over another radical on the side, but I'm not doing that here. It's the same thing. Different books alter the formula, but it's ultimately the same formula, okay? So here's our Z-test statistic for proportions, okay? So proportion, we need P hat 1. And how are we going to determine 1 and 2 in this case? In this case, we're going to determine 1 and 2 by our last video by saying like this was X and this is Y. So I'm gonna call this 1 and 2. Does it matter? Yes, it would matter if it was less than or greater than, okay? So less than or greater than. So if you're given a chart for unequal to, just the first one is 1 and the second one is 2. Again, check with your instructor for that. But as far as I'm concerned, that works for my students. All right. So p hat 1. All right. And what's p hat equal to? All right. X over n. And what are we talking about? We're talking about the number of men ticketed. And I like to write men here just to keep my bearings straight. All right, the number of men ticketed, 11, over the total, right? I can do it in my head, but you can pop it in your calculator, right? 75 plus 11. All right, that's going to be 86. All right, so p hat 1 is going to be equal to what? So pop in 11 over 86 in your calculator. Now, this is what my students have to do, and it needs to be rounded to 4 decimals because it's a probability. So 1, 2, 7, 9. All right, it's p hat 1. Now we're going to do the same thing for p hat 2. I'm going to write everything out for that one. See what we get down there. Okay, and there's p hat 2. I didn't bore you with writing it, but it's still x over n, and you're wondering where I'm getting it. Of course, these are the x's, and the n's are the total. All right, for each of these. So we have our p hat 1 and p hat 2. Let's plug them in at the beginning of the formula, and then again, this is women. All right, just so you know. So you have 0.1279 minus 0.1053, and it's really going to be minus 0 because we don't know what it is. I mean, we don't have it, so. Oh, shucks, we need p hat. That's not p hat 1 or p hat 2. We need p hat. Okay, and there's a formula for that p hat. Again, checking on your formula sheets, you should see that p hat is x1 plus x2 over n1 plus n2. Okay, you have to figure that out also. Right, it's not given to you. All right, so x1 plus x2 over n1 plus n2. Now, I'm not going to fast forward this because this is important. Students put this in the calculator wrong often. Right, 86 plus 114 was the original what? Was the original 200 that was there. Now, sometimes students try to put this in the calculator and you'll get it wrong. So you can finish it up. Just make sure that you put anything that's on top of a fraction. Either you use the fraction button, which I showed you in one of my other videos, or you just use the parentheses. So you have to do one or the other. But you're not going to go 11 plus 12 divided by, what was that? 11 plus 12 divided by 86 plus 114. This will give you the wrong answer every time. Why? Because really quickly, the calculator is going to follow what? What you should follow, the order of operations. And in the order of operations, we would do what? We would do that division first. Then we would go from left to right with our additions. So make sure you do not make a mistake. If you're going to put this in, then put it in using the parentheses for top or the bottom. Or if you want to get fancy and you watch my other videos, you can get the fraction bar and do it that way, because the fraction bar will know to separate the two. All right, but that's going to give you it back in a fraction, and then you would have to go to math number 2. All right, so just so you know, you see the first part, you got it wrong. So either way, that's 115.115. So your p hat, all right, so we're just going to plug this in, and it's 1150 if you want to get credit in my class. Some instructors don't care. all over 1 over 86 plus 1 over 114. All right. So after you show that on your paper, you can get your z-test statistic, right? You can get that simply by going to your calculator and going through the things. Says now I know you know all the numbers and where they go. Because ultimately you would get the answer right. Even if you put all these numbers in jacked up, you would get the answer right because the calculator's right. I'm interested in knowing that you know where the numbers go before you just pop it into the calculator. So we go to stat and we go over to calc. We go over to test, sorry. And then we're doing a what? We're doing a proportion, right? But we're doing a 2 sample proportion test, which is number 6. I'm going to just hit number 6. I'm not going to go down there. Okay, and now we need to put in all our numbers, which I did not put in. So let's go ahead and do that. So I'll wait for you to do it and I'll do it myself. I think 11, 86, 12, 114. It was equal to, and then let's see about calculating this. Okay, and we can see our P1 and P2 are correct, and our P hat 1 and P hat 2 are correct, and our P hat is correct. All right, so you figured it out and then it's correct. So now we need our z-score, which z-score is 2 decimal places, so that's going to be 0.50, okay, 0.50. So your z-test statistic is 0.50. And we go back, if we're going to do the critical value method. All right, now critical value method, remember now we have what? This is a two-tailed test. So you're looking for the critical value to the right or to the left. It doesn't matter. Either one of these will be in the rejection region. The middle region is the fail to reject region, okay? So the critical value method, and what was our alpha? Our alpha was 0.05, all right? All right, but we need 2 sides, all right? We need 2 sides. So alpha is 0.05 divided by 2 because we're looking at both sides. So that's going to be alpha over 2, which is equal to 0.025, okay? So we need to look up 0.025 in our chart, our Z chart. So let's pull up our Z chart. Point 0.025, 0.025. There it is, right here. 0.025. Now let's back that up. All right, negative 1.96, right? Everybody see that? Negative 1.96. So now this time you get 2 critical values. Don't mess it up on your exam. So, or for your instructor. So ZCV or crit is going to be negative 1.96 and positive 1.96, right? And if you draw the picture, you won't forget to put it. So anything outside of those parameters. So now let's see where our z-test statistic of 0.5 is going to fall. All right. So our z-test statistic is going to fall in between those two, and that's in the FTR region. Okay. So what are we going to do? Too bad we got to keep her. We're going to fail to reject the help. All right. We're going to fail to reject it. Fail to reject it again means that we don't have any information either way. It could be true, it could not be true, but according with the data that we have, we do not have enough information to say either way whatever it is that we're trying to prove. Right? So let's check that out here. So talking about in this town whether or not it happens or not, then we can write it out. So do we write there is or there is not? Well, of course, we're going to be writing what? There is not. All right. So there is not sufficient evidence to support the claim that, and you get that right off the top. There's no need for you to try to make up a new, what they say, reinvent the wheel. So that women and men are unequally likely right, to get speeding tickets in the area, right, where these participants were from. All right, because we didn't know the area. In the area where they were from, in this area, right? So there's our conclusion there, right? Taking a look at what they were asking. A citizens group in some place, we don't know where the place is, but we do know that based on the information, the data that they gave us, that there is not sufficient evidence to support the claim that women and men are unlikely, are equally unlikely, equally likely to get a speeding ticket in this area, okay? So that's how you do the not equal to. I hadn't done any not equal to's in the other one. So just remember that if it's not equal to, you're looking for both sides to figure out both sides. You're doing a two-tailed test if it's not equal to. So you have to just divide that alpha out. I didn't use the p-value method for this because it's self-explanatory for that, but most of the time when we work with proportions, we like to do the critical value method. Some of your instructors will be okay with p-value method. That was actually in our calculator. You can go back and check it if you like. Actually, I'll just look in the calculator right now since we're here and show you we had the p-value was 0.6192 there. And I do want to go into this real quick, sorry about that, but look at here, it's 0.6192 if my students use the calculator. My students can't use the calculator, they have to use the chart. So let's check that out to show just this, how it works. So our z-test statistic was 0.50. So let's take a look at our z-score, our z-chart. So 0.50, they will have to go in here and find 0.50. So let's do that. I'm sorry, the z statistic was 0.50, so we have to go find 0.50 because it's a z 0.50. So here we go, right here. So 0.50, right here. Let me bring it up, zoom it in a little, just to show you. Okay, so you can all see it. I'm gonna pull it up just a little bit here. Right, here's 0.50. That's 0.6915. 0.6915. Let's look at the calculator, just so I can drive this home. And the calculator is 0.6192. So depending on your instructor, maybe your instructor doesn't care, but as far as I'm concerned, my students who gave me 0.6915 would get marked correct, and my students that gave me 0.6192 would get it marked incorrect because I'm asking them to use the chart. So make sure that you see what your instructor is asking you for, and you can clearly see the difference between the two. So I know if my student said, no, I used the chart, I'm going to say, no, you didn't use the chart, because the chart is 0.6915 and right, and the calculator is 0.6192. All right, little bit off, lot bit off, whatever you want to call it, but two different things. Okay, so that now takes care of that. I'm glad that I went over that because I don't know whose instructor will need what, but I know what I like. But anyway, that's enough of this. So that is our 4-streak banger in one day. So you will find them all over the place popping in. And also what'll be up here while I'm talking is that subscribe button. So please subscribe to the channel, comment, and like. I just want the comments. I want to know how you feel about it. Again, how's your instructor making you feel about this 2 samples testing? So that's all I'm going to do now. And remember, this is Professor Sampson from PS I Love Math.